to do some projectile motion problems now. The first one we're going to do is chapter 4, number 13. In chapter 4, number 13, it says the supply plane needs to drop a package of food to scientists working on a glacier in Greenland. The plane flies 100 meters above the glacier at a speed of 150 meters per second. So what we got is this. We have an airplane here. It's going with a velocity in the x direction of 150 meters per second. And the height here is 100 meters above the ground. And what they want to do is drop a package to the scientists. So they're going to drop a package, but it has an initial velocity, and once it leaves the plane, it's going to follow a parabolic arc and hit in a spot right here. Okay? So once it leaves the plane, it becomes a projectile. And what we want to do is figure out the distance from where they drop it to where it hits. So they can drop it in at the right time so that the scientists can get it easily. All right. So what we have is we have two things going here. We have initial velocity, but the initial velocity is all in the x direction. The initial velocity in the y direction is 0 because they're flying straight and level. And we're trying to find a distance, but we're trying to find a distance in the x direction. So in the x direction, we only have these two problems. So what we really need to do is this. Well, this is 0. The initial position here is going to be 0. We know the initial velocity, but we don't know time. And so to get the distance, we have to find time. All right, that's our only option. The only way we're going to find time is we're going to find how long it takes it to fall down this way. So in the y direction, we're going to use that to figure out the time. We're going to use the top equation. And I have them written over here, but you should always have them close by so you can reference them. And on the test, you'll be able to use these equations, all right? You can't use your notes, but you can use your equations. All right, so what we're going to say is its initial position is going to be 100. Its final position is going to be 0. So this is 0. This is 100. V0y is 0, right? Minus 1/2 of 9.8 times t squared. So I can solve that for t. So I'm going to move this over here. I'm going to get minus 100 equal to minus 1/2 times 9.8 times t squared. And then the negatives cancel when I multiply by -2, and this becomes 2 times 100 divided by 9.8, and then the square root of that is equal to t. And when I calculate that, I get that the time is 4.52 seconds. Okay, now that I know the time, I can plug that back into my x equation up here and say, oh, then the distance it has to be is just going to be v naught x, which is 150, times the time, 4.52. And so the distance that it's going to go in the x direction is equal to 678 meters. So they have to drop at 678 meters before they get to the spot so that when it falls, it actually hits the right spot. And that's how you do it. It's not too hard. Now the thing to remember is the only thing that's the same in both these is t. And so the time works in both of them. All the rest of them have to have subscripts, if you notice that. But the time, it's the same time for both the x and y coordinates.